Look across any sun-drenched desert landscape. It operates as a crowded, high-stakes marketplace for plant life, where every organism fights for limited resources. The standard botanical strategy relies on a significant expenditure of energy. Plants produce bright red, yellow, and violet petals to capture the attention of passing bees and birds during peak daylight hours. But that high visibility carries a danger. The same vibrant floral display that attracts a pollinator also signals a buffet for the voracious daytime herbivores patrolling the brush. Blooming under the midday sun is a calculated gamble. It creates an environment where species must either outcompete their neighbors for attention or risk being eaten before they can reproduce. Right in the middle of this midday chaos, you will find Nicotiana attenuata, the coyote tobacco plant. While the desert buzzes with activity around it, its flowers sit tightly closed, appearing completely dormant during the peak hours of sunlight. It takes a tremendous amount of moisture and nutrients to survive in dry soil. It seems unusual for a plant to expend those resources building a flower only to stay closed during the most active pollination period. This dormancy is a specific defense mechanism. By keeping its petals tightly sealed during the heat of the day, the plant sidesteps the hungry mounts and the intense competition for pollinators that defines the daytime environment. Coyote tobacco abandons the daylight market entirely. It waits for the high-stakes competition of the afternoon to end, preparing to reveal its own path to survival once the sun sets. The exact moment the sunlight fades from the soil, the drop in temperature triggers the plant's internal circadian clock. The plant actively pumps fluid into the cells at the base of the folded petal, rapidly building internal hydraulic pressure. As pressure peaks, it forces the petal to unfurl. The tight folds yield to fluid dynamics, snapping the flower open in minutes. This results in a wide display of bright white petals. Without the sun's glare to wash them out, that white surface becomes a high-contrast beacon against the dark desert soil. In under an hour, this physical transformation turns an unremarkable weed into a specialized nocturnal lure, timed perfectly for nightfall. Opening the petals is only the first phase. The second they unfurl, the flower vents potent scent compounds into the cooling air, an invisible signal broadcast into the dark. That chemical signal is picked up by the highly specialized night-flying hawk moth, which can track the scent plume directly to the flower. The flower's corolla tube extends deep into the plant, exactly matching the hawk moth's elongated proboscis. This depth acts as an anatomical filter. If a generic daytime insect with a shorter tongue finds the flower, it is physically blocked from the nectar deposit. This architecture creates a strict security protocol. The nocturnal bloom ensures the plant's nectar goes exclusively to its dedicated pollinator, eliminating the risk of daytime theft. Step back from that single flower, and you realize the desert at midnight is an interconnected environment. The darkness is a rich, specialized night shift economy, operating in parallel to the sunlit world. Moths, bats, and countless insects move through the cool air. Within this network, Nicotiana attenuata serves as a keystone resource. It provides the high-energy nectar payloads that keep the ecosystem fueled, using specialized nocturnal insects to carry its pollen across miles of open sand. By exiting the daylight market and securing its own dedicated pollinators, the plant has effectively monopolized a different economy. It has traded the chaos of the sun for dominance of the night. The closed weed baking in the noon sun and the white master of the midnight ecosystem are the exact same organism, simply separated by a few hours. We often assume that sunlight is the sole driver of biological vibrancy, or the only setting for complex adaptation. Yet here, in the harsh desert, some of the most sophisticated survival events require the absolute absence of light to function at all. When the sun goes down, a shadow world activates, proving that for a select few species, the end of the day is exactly when the real work begins.